Hello everyone. I'm Mohamed Salama, and today I will be presenting my final project for the Intro to NLP course. My project is titled Emotion Recognition and Classification Using Advanced Transformer Models. Starting off with a brief introduction. In this research, I explored emotion recognition through advanced natural language processing, developing a multi label classification system that transcends traditional sentiment analysis. By leveraging transformer models, I aim to detect and interpret emotional states from textual data. The challenge was teaching machines to understand the subtle nuances of human emotion, requiring deep understanding of language, context, and psychological expression. My research may have significant implications across multiple domains like mental health monitoring and customer experience, which bridges computational systems with human emotional intelligence through innovative machine learning techniques. Moving onward, to the dataset overview. I worked with the Go Emotions dataset from Google, a corpus of 58,900 Reddit comments offering unprecedented insights into human emotional expression. The dataset was meticulously curated with high quality emotional labels limited to 30 token sequences to maintain focus. Strategically, it was divided into training, 43,410 samples, validation, 5,426 samples, and testing, which was 5,427 samples. This structured dataset enabled me to develop a sophisticated emotion recognition model that captures the nuanced landscape of human communication. Moving onward to the problem statement, I confronted the intricate challenge of automated emotion detection in text, addressing the complexity of human emotional expression. Machine learning approaches struggle with three critical limitations: subtle emotional language nuances, inability to classify multiple emotional states simultaneously, and last, difficulty interpreting context dependent emotions. My key research question was whether machine learning algorithms could truly recognize the multifaceted landscape of human emotions. And by pushing the boundaries of transformer models and innovative classification techniques, I sought to demonstrate computational systems' potential to comprehend the intricate subtleties of emotional communication. Moving onward to my methodology, I tried to design a rigorous, multi stage methodology to address computational emotion detection complexities. The research began with meticulous data preprocessing using advanced text normalization, tokenization, and lemmatization techniques. By leveraging the Roberta transformer model, and advanced embedding techniques, I extracted sophisticated linguistic features capturing nuanced emotional context. The model configuration phase was critical, constructing a multi label classification architecture with a sigmoid activation layer to detect multiple emotional states simultaneously. A key breakthrough was developing a dynamic thresholding strategy that significantly improved classification accuracy. I utilized cutting edge technological components such as TensorFlow, Hugging Face transformers, and skit-learn metrics to bring this complex approach to life, representing a significant step forward in emotion recognition. Moving onward to the model architecture. I designed a sophisticated transformer based neural network architecture using Roberta, meticulously engineered to optimize emotion classification. Starting with the pre trained Roberta base model, I incorporated a dropout layer to prevent overfitting, a dense layer with 512 units for feature transformation, and a sigmoid output layer for multi label emotion detection. Through careful experimentation, I selected training hyperparameters, the optimizer for adaptive learning, a learning rate of 0.01 for balanced model convergence, and a batch size of 16 for computational efficiency. This approach created a robust, flexible emotion classification model capable of capturing nuanced emotional expressions in text data. Moving onward to the performance metrics, I analyzed the emotion recognition's model performance, revealing a nonce understanding of machine learning's emotion detection capabilities. The validation accuracy of 50.41% signifies a breakthrough in multi label emotion classification, with a validation loss of 0.3241 indicating meaningful pattern learning. Category specific performance showed compelling insights. Joy stood out with an impressive F1 score of 0.68, while the neutral category achieved a robust 0.55. However, the model struggled with subtle and complex emotions, highlighting the inherent challenges of computational emotional expression. These results underscore both the potential and limitations of current machine learning approaches to emotion recognition, emphasizing the need for continued research and innovation in this field. Moving onward to threshold optimization. So I tried to develop a dynamic threshold optimization strategy that transformed emotion classification by implementing a unique optimization method for each emotion category. The optimal threshold varied significantly. Joy was at 0.361, neutral was at 0.307, and anger was at 0.211. This nuanced approach more accurately captured subtle emotional differences, with a remarkable 6.71% F1 score improvement in the joy category. The threshold optimization technique proved powerful in recovering performance across multiple emotional states, demonstrating a sophisticated approach to machine learning based emotion recognition that transcends traditional static classification methods. Moving onward to what really worked, I identified critical techniques that advanced emotion recognition model with transfer learning using Roberta, proving transformative by leveraging pre-trained linguistic knowledge and improving contextual emotional understanding. The dynamic thresholding approach overcame traditional fixed threshold limitations by customizing classification threshold for each emotion category. A comprehensive pre-processing pipeline further enhanced performance by cleaning and standardizing input data. These techniques contributed key strengths: enhanced feature extraction, improved classification accuracy, and robust data standardization. By combining these approaches, I demonstrated a sophisticated method of computational emotion recognition. Moving on to the challenges and limitations, I confronted significant challenges that exposed the complexities of emotion recognition through machine learning. Class imbalance emerged as a critical issue, with certain emotions dramatically underrepresented in the dataset, making it difficult to consistently recognize less frequent emotional states. Subtle emotion detection proved particularly challenging, as emotional expressions are nuanced and context dependent, requiring deep linguistic and psychological understanding. Low frequency emotion categories like fear and disgust were especially difficult to classify accurately. Performance variations across emotion categories were stark. While the model excelled with straightforward emotions like joy, it struggled significantly with complex multi-layered emotional states. This limitation highlighted the current boundaries of machine learning in comprehending the depth of human emotional expression, underscoring the need for continued research and more sophisticated computational approaches. Moving onward to the lessons learned, I uncovered profound insights that reshaped my understanding of emotion recognition. The critical importance of threshold optimization became evident. A one size fits all approach cannot capture the nuanced complexity of emotional expression. Moreover, data representation emerged as a crucial factor in model performance. Pre-processing proved to be a powerful lever, with minor modifications slightly impacting classification accuracy. However, the most humbling lesson was realizing no universal solution exists for emotion recognition. Each emotional category, dataset, and context requires a tailored approach. So these insights are not limitations but opportunities. They point toward more sophisticated approaches to computational emotion recognition, inviting further research. Moving onward to the future directions. In reflecting on the potential future of this research, I see exciting avenues for advancing our computational understanding of human expression. Advanced data augmentation techniques could help address the class imbalance challenges, generating synthetic yet realistic emotional examples to enhance model training. Ensemble model architecture represent also a promising approach, combining multiple machine learning models to create a more robust and nuanced emotion detection system. By leveraging the strengths of different architectures, we can potentially overcome the limitations of individual models. Sophisticated threshold optimization remains a critical area for innovation, and my research demonstrated the power of dynamic thresholding, but there's still a significant room for more advanced techniques that can adapt even more precisely to different emotional categories. Lastly, to conclude, I would like to say I tried to develop a groundbreaking approach to emotion recognition that challenges traditional computation limitations. The novel multi label emotion classification methodology demonstrated a significant leap forward in understanding emotional expressions for me in my research. Also, this research provided insights into transformer model performance, revealing the capabilities and challenges of advanced neural networks for emotional analysis. Also, by creating a flexible emotion recognition framework, I opened new pathways for interdisciplinary research at the intersections of linguistics, psychology, and computer science. The potential real world applications are profound, ranging from mental health monitoring to enhancing customer experience and developing more empathetic human computer interaction interfaces. So ultimately, this research could potentially bridge the gap between computational systems and the nuanced landscape of human emotional expression. This was the presentation for my project. I will be open to any questions and please let me know at any time if you